The oceans nearly killed everything. Number 10. The Permian Great Dying. 96% of everything living in the ocean died, and it took the planet over 10 million years to recover. Around 252 million years ago, in what we now call the Permian period, the oceans began to die. Not slowly, not gently, they suffocated. Volcanic eruptions tore open the earth across a region we now call Siberia, releasing lava on a scale the world had never seen. The ground split. The fires burned for hundreds of thousands of years, and the oceans absorbed the blow. The water warmed. The currents that once carried oxygen from the surface down into the deep simply stopped. The oxygen vanished from the sea like breath leaving a body. This was not a local disaster. This was not a regional die-off. This was the end of nearly all marine life on the entire planet. 96 out of every 100 species in the sea gone. Corals that had built reefs for millions of years gone. Armored fish that had ruled the deep gone. The tiny shelled creatures that formed the very floor of the ocean gone. The water turned stagnant from top to bottom. The deep sea became a dead zone stretching from pole to pole. Nothing moved. Nothing grew. The ocean became a body with no pulse. Consider what came later. The extinction that killed the dinosaurs took out perhaps half of marine life. The Great Dying took out nearly all of it. It was not a close cousin to other disasters. It was the father of them all, the worst mass extinction the ocean has ever known. Nothing before it or since has come anywhere close. The numbers are not just large. They are near total. The ocean came as close to death as an ocean can come and still recover. You could have walked to the shore and seen nothing alive. The tide pools would have been empty shells and silence. The shallow seas that once teemed with life would have been still and warm like bathwater left too long. The deeper you went, the worse it got. No fish, no movement, no light flickering with living things. Just water. Warm, dead, empty water stretching to every horizon. But here is where the mystery begins. What exactly choked the life from the sea? Some researchers point to volcanic gases flooding the atmosphere and superheating the oceans. Others argue that methane frozen deep in the seafloor melted and flooded upward, stealing whatever oxygen remained. A few believe the water simply became too warm to hold oxygen at all, that the heat itself was the weapon, and everything else followed. Each theory explains a piece of the death. None of them explain all of it. The truly unsettling implication is this. If the ocean can lose its oxygen this completely, if it can go from thriving to nearly dead in what may have been just a few thousand years, then the ocean we rely on today is not permanent. It is not a guarantee. It is a thin, fragile skin of life sitting over a darkness that has swallowed everything before. The same water that cradles all life on Earth can become its grave. It has happened once. There is nothing preventing it from happening again. We do not know how fast the dying truly spread. We do not know which creatures fell first, or which ones held on the longest in the last pockets of breathable water. We do not know what the ocean looked like when the silence finally settled, whether the water was clear and empty, or green with decay, or black with the rot of a billion dead. The seafloor holds the bones. The bones are not speaking. Number 9. The Chicxulub Mega Tsunami. A wall of water 1.5 miles tall moved faster than sound across the ocean, and there was nowhere on Earth to hide from it. If you want to see more videos like this, make sure to subscribe. 66 million years ago, in what is now the Yucatan Peninsula, a rock fell from the sky. Not a small rock. A mountain 6 miles wide, moving faster than a bullet. It struck the shallow ocean with a force that words cannot hold. The impact vaporized the water above it. The seafloor melted into glass. And within seconds, a wave was born, a wall of water 1.5 miles tall, racing outward in every direction at the speed of sound. The wave did not creep toward the coast. It did not rise gently. It slammed into the shorelines of North America, South America, Europe, and Africa within hours. Coastal forests were ripped from the ground like grass. Cliffs that had stood for millions of years shattered into rubble. Anything living within miles of the ocean on land or in the shallows was swept away, buried in mud, or simply erased. The water carried boulders the size of houses. It tossed them inland like pebbles. No coastline was safe. No bay was sheltered. No creature near the sea had any warning at all. The wave crossed the entire Atlantic basin in less than a day. It wrapped around the globe, bouncing off continents, rebounding, striking again. The chaos did not stop in hours. It went on for days, the ocean sloshing like water in a kicked bucket, each surge carrying debris and death further inland than the last. Picture yourself standing on a beach that day. The sky would have flashed white, brighter than the sun, brighter than anything you have ever seen. Then the sound would have come, not a crash, a roar that shook the ground beneath your feet. And then on the horizon, the water would have risen, not like a normal wave, like a moving wall taller than any building, wider than you could see, coming faster than you could run. You would not have had time to be afraid. You would not have had time at all. But here is where the mystery deepens. How did the wave behave in the deep ocean? Some scientists say it may have been a full mile tall even in open water. Others believe the impact created not one wave but a series of them, each one feeding the next, each one stronger than the last. A few think the wave may have been even larger than we calculate, that the evidence was erased by the wave itself. Each model shows a wall of water. None of them agree on its full shape. The truly unsettling implication is this: the ocean is not a shield. It is a weapon. When enough force strikes it, it does not absorb the blow, it carries it. Every coastline on Earth sits in the path of a weapon that has already fired once. The asteroid did not just kill the dinosaurs. It turned the sea into a battering ram that hit every shore on the planet at the same time. We do not know exactly how far inland the water reached. We do not know how many waves there were or how many died in the first hour alone. We do not know what was lost in that first surge, what coastlines, what creatures, what evidence was simply scrubbed from the earth without a trace. The water came. The water left. What it took remains gone. Down to number 8. The Messinian salinity crisis. The Mediterranean Sea vanished completely, replaced by a desert of salt 3 miles deep, where nothing could survive. Nearly 6 million years ago, the sea that we now call the Mediterranean simply stopped existing. Not gradually, not over millions of years. The Strait of Gibraltar, the narrow mouth that connected the Mediterranean to the Atlantic, closed. The land rose up and pinched the water off from the ocean beyond. And then the sun went to work. The water evaporated. Year after year, century after century, the sea shrank. What remained was a basin, a pit of salt and heat 3 miles deep, stretching from Spain to the Levant, where water had been just moments before in geological terms. No fish survived, no coral, no seaweed, no plankton. Nothing that had lived in the Mediterranean could live in a desert of salt. The temperatures at the bottom of the basin would have been lethal, hot enough to boil away any moisture that drifted in. The air above it would have been thick with salt, dry as bone, hostile to any life that tried to cross. An entire sea, home to countless species, became a grave the size of a continent. You could have stood on the edge of the basin and looked down. The drop would have been staggering, 3 miles straight down to a floor of crystallized salt. The air would have been dry and heavy, pressing against your chest. Below you, there would have been no movement, no waves, no tide. Just a flat, white plain stretching farther than the eye could follow, a graveyard where a sea used to be. Think of what was lost. The Mediterranean was not a small body of water. It was a world, its own ecosystem, its own currents, its own chain of life from the surface to the deepest floor. All of it gone, replaced by a white crystalline emptiness. The rivers that once fed into it, the Nile, the Rhone, the Po, carved deep canyons through the exposed rock as they fought to reach the shrinking water. Those canyons are still there. You can see them today, buried under the sea, carved into the seafloor like scars from a wound that has not healed. But here is where the mystery opens. What caused the strait to close? Some geologists say tectonic plates simply pushed the land upward, sealing the gap. Others argue that sea levels dropped globally, cutting off the flow. A few believe it was a combination of both, the land rising and the ocean falling at exactly the same time. Each theory fits some of the evidence. None of them fit all of it. The truly unsettling implication is this: a sea can die. Not just the life within it, the sea itself. An entire body of water larger than some continents can be erased from the face of the earth. The land can rise, the connection can be cut, and the sun can drink it dry. If it happened to the Mediterranean, it could happen again. To any sea, to any coast. The map we trust is not fixed. It is temporary. We do not know how long the basin stayed dry. We do not know if any life clung to the edges, in salt pools, in deep brine, in the last damp corners of a dead sea. We do not know what the desert looked like from above, whether it was white with salt or brown with dust or cracked like old bone. The sea came back eventually, but the dead basin, it still waits beneath the waves, silent, salty, patient. At number 7, the Great Oxidation Event. The gas that keeps you alive once poisoned the ocean and killed the very organisms that made it. 2.5 billion years ago, the ocean was nothing like the water we know today. There was no oxygen in it, none. The water was thick with iron and sulfur, and the creatures that lived in it, tiny, simple, invisible to the eye, breathed something other than oxygen. They breathed what we would call poison, and they thrived. The ocean was theirs. The whole planet was theirs. The sky was not blue. The land was bare rock. The sea was a soup of dissolved metals and strange gases, and in that soup, life had found a way. Microbes appeared in the shallow water, tiny organisms that had learned a new trick. They took in sunlight and released oxygen. Billions of them, trillions. They flooded the water with a gas that, to the creatures already living there, was deadly. Oxygen corroded their cells. It broke down the chemistry that kept them alive. It was not a gift. It was a weapon, and it was being made by life itself. You could hold a handful of that ancient water and not recognize it. It would have been dark, thick with minerals, heavy with compounds that would smell like rotten eggs. No fish would swim through it. No coral would grow in it. It was a different ocean entirely, alien, hostile, alive in ways we are only beginning to understand. No escape existed, no refuge. The oxygen did not stay in one place, it spread. It seeped into every corner of the ocean. It reacted with the iron in the water, turning it to rust that rained down on the seafloor. The water changed color, the chemistry shifted, and the old microbes, the ones who had ruled the earth for hundreds of millions of years, began to die. Not all at once, but steadily, completely. They were being poisoned by the very thing that would one day make all complex life possible. But here is where the mystery darkens. Why did the oxygen spike when it did? Some scientists say the microbes simply reached a tipping point, enough of them producing enough oxygen to flood the sea. Others argue that something changed in the Earth's geology, allowing oxygen to build up instead of being absorbed by rocks and iron. A few believe a burst of volcanic activity forced the change, altering the ocean's chemistry from below. Each idea makes sense on its own. None of them explain the timing. The truly unsettling implication is this: the thing that makes your life possible was a mass extinction event for something else. Oxygen was not always a friend. It was once a killer, the worst killer the ocean had ever seen. Life did not just adapt to oxygen. Life was slaughtered by it. And from that slaughter, a new kind of life emerged. Your existence is built on the graves of the creatures that oxygen destroyed. We do not know how many species vanished in the poison tide. We do not know how long the dying lasted, whether it was fast or slow, whether it came in waves or in one long flood. We do not know what the ocean sounded like before the oxygen came, or what silence it left behind. The water kept moving. The old world dissolved. Something new took its place. The dead are still there, buried in the iron, buried in the rust, buried in the silence. Number 6. The end-Triassic stagnation. 4 out of every 5 creatures in the sea suffocated at the same time, and the water itself was to blame. Around 201 million years ago, the supercontinent we call Pangaea began to rip itself apart. The land split along a seam that would one day become the Atlantic Ocean. Magma erupted from deep within the Earth, and lava poured across the surface for hundreds of thousands of years. The eruptions did not stop. They pulsed wave after wave, each one releasing heat and gas into the atmosphere and into the sea. The ocean swallowed that heat. The water warmed from the surface down to the deepest trenches, and that warmth killed something vital. In a healthy ocean, cold water sinks and warm water rises, a simple cycle that carries oxygen from the air down into the dark. But when the water grew too warm, that cycle broke. The cold water never sank. The oxygen never traveled. The deep sea was sealed off from the world above, and everything living below the surface began to choke. 4 out of every 5 marine species died. Not in one corner of the world, not along one coast, everywhere. The reefs that had grown for millions of years, gone. The shellfish that carpeted the shallow floors, gone. The early marine reptiles that had just begun to hunt in the warm shallows, gone. The extinction did not choose. It did not spare the strong or the fast or the clever. It killed almost everything with the same flat, silent efficiency. The sea floor became a wasteland. The sediment turned black with organic matter, the remains of dead things that had sunk from above because there was nothing left alive to eat them. Layer upon layer of dead plankton, dead shells, dead bones piled up in the dark. The ocean was not just empty, it was burying its own. The water above was warm and still. The water below was black and dead, and the space between them was silence. But here is where the mystery opens. Why did the stagnation spread so far and so fast? Some researchers say the volcanic heat alone was enough to warm the entire global ocean. Others argue that carbon dioxide from the eruptions trapped so much warmth in the atmosphere that even the deep sea could not stay cold. A few believe the ocean's circulation was already failing, and the eruptions simply pushed it over the edge. Each theory explains the warming. None of them explain the speed. The truly unsettling implication is this: the ocean's ability to breathe is not a given. It is a system, and systems break. The water that covers most of the planet can turn into a sealed tomb, cut off from air, dead from below. It happened once. The conditions that caused it are not impossible to imagine again. Warm the water enough and the currents stop. Stop the currents and the deep sea dies. It is that simple. It is that fragile. We do not know how quickly the last pockets of oxygen vanished. We do not know whether anything survived in the shallows, or if the dying reached every shore on Earth. We do not know what the water looked like as it suffocated, whether it went clear and empty, or dark with the rot of the dead. The sea kept its silence. The dead kept theirs. Number 5. The late Devonian Kellwasser event. The first plants on land didn't just grow. They drained the ocean of oxygen and murdered the sea. 372 million years ago, something happened to the ocean that no one could have predicted. The land, which had been bare rock for billions of years, turned green. Plants appeared, not towering forests. Small, simple plants with shallow roots, clinging to stone and dirt for the first time in Earth's history. They spread quickly, covering what we now call Europe, North America, and parts of Asia. And as they grew, they changed everything. The plants broke the rock apart. Their roots dug into the stone, releasing nutrients that had been locked underground for ages. Rain washed those nutrients into streams. Streams carried them into rivers. Rivers poured them into the sea. The ocean received a flood of food it had never seen before, and it reacted in the worst possible way. Algae bloomed, not in one place, not in small patches. Across the entire surface of the sea, algae exploded in numbers too vast to count. The blooms covered the water like a blanket. Sunlight could not reach below the surface. And when the algae died, as algae do, they sank. Their bodies fell into the deep, and as they rotted, they consumed oxygen. Billions upon billions of tiny dead organisms, each one stealing a breath from the sea. The oxygen dropped, then it dropped more, then it was gone. The creatures that had ruled the Devonian seas did not stand a chance. The great placoderms, fish as long as cars, with jaws that could crush bone, died. The early reef builders that had constructed vast underwater cities from calcium and time died. The smaller fish, the bottom feeders, the scavengers, all of them died. Not because the water grew too hot, not because a rock fell from the sky, because the land grew green and the ocean paid the price. What makes this particularly disturbing is the source of the killing. The disaster did not come from below. It did not come from space. It came from life itself. Plants, the most harmless, peaceful, still things on Earth, triggered a chain of events that turned the ocean into a suffocating tomb. The very act of growing, of spreading, of living was enough to murder the sea. Some scientists say the nutrient flood was a one-time event, a burst of growth that the ocean simply could not handle. Others argue that it happened in pulses, each wave of plant expansion triggering a new bloom, a new die-off, a new wave of suffocation. A few believe the ocean was already struggling, and the plants simply finished what had already begun. The truly unsettling implication is this: life can destroy life, not through violence, not through intent, through growth. The same force that fills the world with green can empty the sea of breath. The link between the land and the ocean is not just a connection, it is a chain, and when one end pulls, the other end drowns. We do not know how many species vanished in the bloom. We do not know how far the dead zone spread, whether they touched every coast or left pockets of life clinging to the edges. We do not know what the first plants would have seen if they could look down from the shore, a sea turning dark, a sea going still, a sea dying beneath a sky they had just begun to fill. The green kept growing, the blue kept fatting, the silence filled the space between. Entry 4. The PETM ocean acidification. The ocean became so acidic that shells dissolved on contact, and the bottom of the food chain collapsed in what may have been just a few thousand years. 56 million years ago, in what we now call the Paleocene epoch, the ocean began to change in a way no creature living in it had ever experienced. Something, no one is entirely sure what, released a massive amount of carbon into the atmosphere. It may have been methane frozen in the seafloor. It may have been volcanic eruptions burning through ancient coal beds. It may have been both. Whatever the source, the carbon flooded the air, and then the carbon sank into the sea. The ocean absorbed it. That is what oceans do. They take carbon from the air and pull it down into the water. But this time the amount was too much. The water's chemistry shifted. It became acidic, not like vinegar, not like something that would burn your skin, but acidic enough to do something terrible. It began to dissolve calcium carbonate, the material that shells are made of, the material that coral is built from, the foundation of life at the bottom of the sea. The shells did not just weaken, they melted. The tiny organisms that built their bodies from calcium, the plankton at the base of the entire food chain, the creatures that fed the fish that fed the larger fish that fed everything else, found that the water around them was eating their armor. New shells could not form. Old shells began to thin, and then they began to crumble. This was not a slow decline. This may have happened in just a few thousand years, a heartbeat in geological time. The base of the food chain collapsed. The creatures that depended on the shelled plankton went hungry. The creatures that ate those creatures went hungry next. The starvation moved up the chain like a wave, and at the bottom, the shells kept dissolving. No reef was safe. No shallow sea was spared. The acid did not stay in one basin. It spread through every current, every channel, every stretch of open water. The deep sea suffered most. The cold, dark depths where creatures had built their shells slowly over centuries, those shells dissolved fastest of all. The seafloor became a graveyard of broken calcium and empty husks. But here is where the mystery deepens. Where did the carbon come from? Some scientists point to methane hydrates, frozen pockets of gas buried in the mud of the deep seafloor that melted and burst free. Others argue that massive volcanic eruptions in what is now the North Atlantic burned through coal deposits, flooding the sky with carbon. A few believe it was a combination, that the volcanoes warmed the earth just enough to trigger the methane, and the two together pushed the ocean past its breaking point. Each theory has evidence, none of them have proof. The truly unsettling implication is this: the ocean is not a stable container. It is a chemical system, and that system can be pushed past its limits. When carbon enters the water faster than the water can handle, the chemistry changes. The shells dissolve. the food chain breaks, and the creatures that depend on that chain, including, one day, us, are left standing on nothing. We do not know how many species disappeared in the acid tide. We do not know how long it took the ocean to recover, whether it recovered in thousands of years or hundreds of thousands. We do not know what the water felt like to the last shell-bearing creature alive, whether it felt the armor thinning around its body, whether it felt the sea turning against it, whether it felt anything at all before the water won. The shells are gone. The silence remains. Entry 3. The Ordovician glaciation. Sea levels dropped over 300 feet in what may have been a geological instant, and every shallow sea on Earth simply vanished. 444 million years ago, the world was mostly water. The land that existed was gathered near the South Pole, a vast, silent continent we now call Gondwana. The ocean covered nearly everything else. Shallow seas stretched across what would one day become North America, Europe, and parts of Asia. These warm, sunlit waters were home to the first great reefs, not made of coral but of sponges and ancient organisms called bryozoans, building walls of living stone on the sea floor. Life was thriving. Life was expanding. And then the cold came. No one warned the ocean. No one told the creatures living in the shallows that the world was about to freeze. But something triggered a glaciation, a sudden, brutal ice age that locked up massive amounts of seawater in ice sheets at the South Pole. The water that had filled the shallow seas disappeared. Sea levels dropped over 300 feet, and the warm, sunlit homes of countless species drained away like water from a bathtub. The shallow seas did not just shrink, they vanished. The reefs that had taken millions of years to build were left high and dry, exposed to air, to sun, to wind. The sponges died. The bryozoans died. The trilobites that had crawled across the sea floor for tens of millions of years, many of them died too. The water retreated, and the creatures that could not follow it were left behind to bake and crumble on empty stone. 85% of all marine species disappeared, not in one region, not in one ocean, across the entire planet. This was the second worst mass extinction the ocean has ever known, worse than the one that killed the dinosaurs, worse than nearly anything before or since. And the weapon was not fire, not poison, not a rock from space. It was ice. Imagine standing on what had been a coastline just centuries before. The sea is gone. The floor is exposed, a flat gray plain of dead shells and dried sponge skeletons stretching to the horizon. The air is cold now, colder than it has been in millions of years. The wind carries no moisture. The tide pools are empty. The reefs are crumbling in the dry air. Everything that once lived here is gone, and the water is nowhere in sight. But here is where the mystery deepens. What caused the ice to come so suddenly? Some researchers believe volcanic eruptions slowed, reducing carbon dioxide in the atmosphere and letting the planet cool. Others argue that the first land plants, small, primitive things, pulled enough carbon from the air to trigger the freeze. A few think the ocean's currents shifted, carrying warm water away from the poles and allowing ice to build. Each explanation is plausible. None of them are certain. The truly unsettling implication is this. The sea level is not fixed. It can drop hundreds of feet in what may have been a geological blink. The shallow waters where life thrives, where reefs grow, where the food chain begins, they can be drained away. The land does not need to rise. The water simply leaves, and when it goes, it takes everything with it. We do not know how fast the water fell. We do not know if the creatures had time to retreat, or if the sea simply dropped out from under them. We do not know what the exposed seabed looked like after the waves stopped, whether it was white with dead shells, or gray with dried mud, or bare and clean as bone. The ice melted eventually. The water returned. But the world it came back to was not the same one it left. Before the last, number 2. The Tortian Oceanic Anoxic Event. The deep ocean died so completely that its remains became the oil we pump from the ground today. Around 183 million years ago, in what we now call the early Jurassic period, the deep ocean began to die. Not the surface still shimmered under the sun. Not the shallows still held fish and coral in motion. The deep, the dark water at the bottom of the sea, where light never reached and creatures moved slowly through the cold, that water lost its oxygen, and everything living in it suffocated. The seafloor became a graveyard. Billions of marine invertebrates, ammonites with coiled shells the size of dinner plates, brachiopods that had clung to the dark rock for generations, sea urchins that crawled through the mud, all of them died. Their bodies sank into the sediment. The mud covered them. The weight of the water above pressed them down, year after year, century after century, until the dead became stone. That stone turned black with carbon. That black stone became oil, the oil we now drill from beneath the North Sea, from beneath the deserts of the Middle East, from beneath the floors of oceans we can barely reach. The dead did not disappear. They became fuel. But here is where the mystery begins. What starved the deep sea of oxygen so completely? The ocean had survived warming before. It had survived eruptions before. It had survived shifts in its currents. But this time, the oxygen did not just dip. It vanished from the bottom up. The death was total. The death was global. The death left behind a black stripe in the rock that geologists can still see today, a dark line running through cliffs and quarries, marking the exact moment when the life stopped and the silence began. You can stand in front of that line today and touch it. Below it, fossils. Above it, nothing. Some scientists point to massive volcanic eruptions in what is now the southern hemisphere, eruptions that flooded the atmosphere with carbon and warmed the ocean until its currents simply failed. Others argue that methane burst from the seafloor in a single catastrophic release, consuming whatever oxygen remained in the deep. A few believe the oceans simply stagnated on their own, that the warmth was enough to stop the water from mixing, and the deep sea suffocated in silence, with no help from anything above. Each theory explains the heat. None of them explain the totality. The truly unsettling implication is this: the oil we burn today is the remains of a mass extinction. The fuel that powers our cars, our ships, our planes, is made from the bodies of creatures that died because the ocean lost its breath. Every drop of it is a fossil of suffocation. Every tank of gas is an echo of the deepest, quietest disaster the sea has ever known. The energy that built the modern world was born in the worst death the ocean ever suffered. We do not know how long the dead zone lasted, whether it lingered for centuries or for hundreds of thousands of years. We do not know how deep the oxygen loss went, whether it touched every trench or left pockets of life clinging to the coldest corners of the abyss. We do not know what the ocean looked like from above, whether the surface was calm and blue, hiding the black death below, or whether even the water on top could feel that something beneath it had gone terribly wrong. The dead are still there, locked in stone, pressed into oil, buried under miles of silence. They do not rest, they burn. Number 1, the one that stays. The Storiga Slide. An entire country disappeared beneath the waves in a single night, and we still don't know if anyone saw it coming. 8,200 years ago, in what is now the North Sea between Norway and Britain, a piece of the ocean floor simply broke away. Not a small piece, not a hillside, not a cliff. A section of seafloor larger than Scotland, 3,500 cubic kilometers of sediment, collapsed all at once. The water above it had no warning. The land beside it had no chance, and the wave that followed changed the map of the world forever. The displacement was instant. The water surged upward, then outward, then forward, a wall of sea racing toward the coastlines on every side. The wave struck Norway first, black water hitting the fjords with force enough to tear rock from rock. Then it swept across Doggerland, a vast stretch of fertile land that connected Britain to mainland Europe. Doggerland was not a small island. It was not a narrow bridge. It was a country rich with rivers, thick with forests, alive with marshes and wildlife, and people who had lived there for thousands of years. The wave consumed it. The water erased it. The land simply went under, and the sea closed over it like a mouth. What makes this particularly disturbing is not just the size of the wave. It is what we cannot find. No record of warning, no sign that anyone fled, no trace of the people who lived on that land, not their bones, not their tools, not their homes. Nothing survived. Nothing was buried with care. Nothing was left behind to tell us what happened in those final hours. A country existed one day and was gone the next, and the sea kept every secret. Some geologists say the slide was triggered by gas hydrates melting deep in the sediment, that the seafloor simply lost its grip and gave way. Others argue that an earthquake shook the continental shelf loose, sending the whole mass sliding into the deep. A few believe the land was already unstable, that centuries of rising sea levels had weakened the edge of the continent, and the collapse was only a matter of time. Each theory fits the shape of the damage. None of them are confirmed. How many people lived on Doggerland? We do not know. Did they see the water coming? Did they have time to run, to grab their children, to climb the nearest hill, to turn and watch everything they knew disappear beneath the gray? The questions answer themselves in silence. A country was erased, not over millions of years, not over centuries, but possibly in a single night. And the sea kept it. The sea has never given it back. The sea never will. We do not know their names. We do not know their stories. We do not know if anyone stood on a hilltop in the dark and watched the water take everything below, the forests, the rivers, the homes, the fires, the life they had built over generations. The sea is calm now. The North Sea stretches flat and gray from Norway to Britain. But the land is gone. The people are gone. The water remains. Something is still buried down there, something still forgot, something still sliding back into the dark.